Jai Shri Gurudev. Now let us determine the centroid of a sector of a circle. So here let me consider this to be x-axis, this is going to be a y-axis. It's a sector, so a small piece of a circle is going to be considered. The radius of the circle is going to be as usual r. I'm going to consider an elementary strip like this. Okay, so this is my elementary strip. As usual, the angle is going to be theta and this angle is going to be d theta. This distance is going to be r d theta. The centroid is going to lie over here. Project it onto your x-axis. This distance is going to be 2 by 3 r cos theta. All of this is going to remain the same. Now this is a sector, so the overall angle is going to be alpha. This is the new addition when compared to your semicircle as well as quarter of a circle. So first let us write what is the area of elementary strip. How we have considered it as a triangle previously, same we are going to do this, same we are going to do now. So it is half into base is r, height is r d theta. This is area of elementary strip, and then the projected distance onto your x-axis is 2 by 3 r cos theta. Now let us find what is the area of the sector or area of your total figure that is present. Can you see that the angle ranges from 0 to alpha? So just take it as 0 to alpha and take up your elementary strip, half into r square d theta. So it is nothing but half r square into theta after integration 0 to alpha, or it is half r square alpha. This is the total area of your given sector. So after this we are going to consider moment of area of elementary strip. So if I'm going to consider moment of area of the elementary strip, I need to first write down the area of the strip, which is half r square d theta, followed by the perpendicular distance, which is 2 by 3 r cos theta. 2 gets cancelled, then it is going to be r cube divided by 3 cos theta into d theta. The next step is going to be sum of moments of such elementary strip. So what is the integral? 0 to alpha, the same thing. So it is 0 to alpha r cube divided by 3 cos theta d theta. After integration it is r cube by 3 sin theta between the limits 0 to alpha, or r cube by 3 sin alpha. So call this as equation 1. Then it is moment of total area about y-axis. What is the total area? We have found it out. Half into r square alpha. Half r square alpha into x bar. Call this as equation 2. As per principle of moments or Varignon's theorem of moments, we can equate both the equations. So it is r cube by 3 sin alpha, which is equal to half r square alpha into x bar, or x bar is equal to, can you see here, r square and r cube gets cancelled, we are left with only r. So x bar is equal to 2 goes to the numerator, 2r by 3 sine alpha. Okay, or moment of area of elementary strip about x-axis. If you're going to do this about x-axis, then it is, instead of cos, it is sine. So 2 by 3 r sine theta, this is the perpendicular distance, half r square d theta is going to be your area. So this is equal to r cube divided by 3 sine theta d theta. Then the sum of moments of such elementary strips about y axis. So this is integral 0 to alpha r cube divided by 3 sine theta d theta, which is r cube by 3 1 minus cos theta 0 to alpha, or this can be written as r cube by 3 1 minus cos alpha. This is my equation 3. Now moment of total area about y-axis, sorry, this is about x-axis, and this is also about x-axis. About x-axis is going to be r square by 2 alpha into y bar. Call this as equation 4. Equate equation 3 and 4. It is r cube by 3 1 minus cos alpha equals r square by 2 alpha into y bar, or y bar is equal to r square gets cancelled over here. You're left with only r. 2r divided by 3 into 1 minus cos alpha. So x bar, we have got it as 2r by 3 sin alpha. Y bar, you have got it as 2r divided by 3 into 1 minus cos alpha. Now you can see that here we have neglected this alpha, as well as here also we have neglected this alpha, because it is a very small number. It can be neglected, hence it's too small to be considered. That is the reason we have written x bar is equal to 2r by 3 sin alpha, and then y bar is equal to 2r by 3 1 minus cos alpha.